Hi, my name is Aaliyah Lewis. I'm a member of the Forensic Science Masters 2020 cohort, and I'm going to be talking to you about drug metabolism today. So, just to review quickly the order of drug metabolism in general, we have absorption, distribution, metabolism, and excretion. And these are all affected in one way or another by sex, body weight, health status, age, race, genetics, drug interactions, and how recently a person ate. Not necessarily will all of these absorption, distribution, metabolism, and drug excretion be affected by how recently a person ate, but it is something that affects metabolism in general. So those are just all things that affect metabolism in general. So, again, quickly to review, assuming we're looking at an orally administered drug, the drug is going to enter the mouth, go through the esophagus into the stomach. Once it goes to the stomach, those high pH stomach acids begin to make the drug unionized to increase its ability to enter the bloodstream. From the stomach, the drug is going to enter the small intestine, where about 70% of absorption takes place, and it's going to then enter the bloodstream for distribution. The drug is going to be distributed around the body. I like to kind of think of it as one of those fair rides that kind of just do loops. It's kind of what your blood's doing in your body. It's just looping around. And once it gets out of the small intestine, it's going to loop right into the liver for the main site of metabolism. So, the metabolism part of drug metabolism is the process that breaks down a drug or chemical so it can be excreted by the body. Through the process of metabolism, drugs can either be made active or inactive. And most times, both will actually happen. There's some factors that just affect metabolism, and those are genetics, age, drug interactions, and health status. Genetics can be affected by polymorphisms or changes in the genes majorly responsible for the breakdown of drugs. Age can be a factor. Elderly people are more likely to have a reduced metabolism, and children are likely to have underdeveloped organs. This is why when you see children acetaminophen or children Tylenol or children Motrin, it's because the drug needs to be made in a way that their tiny little bodies can process it effectively without the drug hurting them. Drug interactions can lead to decreased metabolism by enzyme inhibition or increased drug metabolism by enzyme induction. Health status, various health conditions can affect metabolism, such as circulatory problems or liver problems, but metabolism as a whole could be affected by a whole host of other health conditions. Drug metabolism, like I said, occurs in the liver and it can be broken down into two phases. In phase one, the parent drug is converted into a more water soluble, more polar metabolite through the addition of polar functional groups. And phase two continues the breakdown of the drug to prepare for excretion. Phase one metabolism converts an inactive prodrug into an active metabolite. This phase involves oxidation and reduction and hydrolysis reactions to increase the water solubility of the drug through the addition of polar functional groups such as OH, SH, and NH2 groups. This is usually done by the P450 family of enzymes. You'll see a little example of those later on. After the addition of these polar groups, the metabolite enters the circulatory system again, where some of the metabolites will either go into their target cells or they will be cycled back around the body and go back to the liver, where they'll either go through another round of phase one metabolism or they will enter phase two metabolism. So once a metabolite has served its purpose, it will go on to phase two metabolism, in which it is going to be either acetylated or affected by glucuronidation or sulfaction reactions. And these conjugation reactions increase the water solubility even more. And the sole purpose of this is to prepare the metabolite for excretion. Here is just kind of a little rough breakdown of metabolism in general. So R is the drug. It's usually pretty lipophilic, and you can see on the other side that we want to get to very hydrophilic. So phase one, we're going to start in either that oxidation or that reduction pathway. We're going to go one of those two ways. If the drug is oxidated, then it's going to go through the conjugation reaction to become hydrophilic in phase two metabolism. And if it goes through a hydrolysis reaction, it's going to go into either sulfaction, acylation, or glucuronidation to become hydrophilic. And then you can see that also is dependent on whether it is a nucleophile or a electrophile. And then here we have a comparison of two different parent drugs. In this example, the drugs that have the asterisk next to them represent active metabolites. And this is a really important part of forensic science, forensic toxicology in general, because when you're handed a tox screen or toxicology test result, you might see that a person has morphine in their system, and a lawyer could be like, they have morphine in their system, they definitely took heroin. And that's when you kind of, as a toxicologist, have to be like, wait a second, there's more than one way that that person could have had morphine in their system. The biggest indicator for heroin exposure is that 6-acetyl morphine, or 6-AM. And that is what heroin is immediately broken down to when it enters the body before being broken down into morphine. But you can see that codeine is also broken down into morphine, but codeine is also broken down into hydrocodone and hydromorphone, which are both active metabolites and are both drugs that can be taken on their own. So another instance, as a toxicologist, you might get a lab result that has that the person took hydrocodone, hydromorphone, and morphine. And the lawyer of the lab is like, wow, like this person took a lot of drugs. And as a toxicologist, especially because you become very familiar with the pathway of specific opioids such as codeine and heroin, you could say, yeah, definitely they might have taken these three drugs and just been really high off of that. But it's also possible that this person took codeine either licitly or illicitly, and that's how those other drugs and those metabolites got there. And this can kind of be seen through the levels of those drugs in the system. For instance, if someone just takes morphine, then obviously that's going to be the only drug in there. It's going to be pretty high levels. But for codeine, the drug isn't evenly broken down into hydrocodone, hydromorphone, and morphine. So you might see them at varying levels, and that'll also be a helpful indicator that the person took codeine and not just straight morphine, or a mixture of the drugs. And then on this slide too, you can see the differentiation between phase one and phase two metabolism. So what I said before on that slide that was talking about the CYP450 genes, you can see here that there are several several enzymes that are in that smaller font. There's CYP2D6, CYP3A4, and CYP2C8, and those are all oxidation reactions that are done through the CYP450 family of genes. And then you can also see that, for example, from hydromorphone to hydromorphone 3 glucuronide, there's that UGT2B7 gene or enzyme, and that is part of phase two metabolism. And so what I like about this graphic too is it shows you, for example, codeine to hydrocodone to norcodeine is metabolized only through phase one metabolism. So before, when I was saying that a drug doesn't necessarily have to go through phase two metabolism, sometimes it can be excreted just after phase one metabolism. That's a great example. And then just to connect it back once again, once drugs have reached the desired level of water solubility, they can be excreted out of the body. Most drugs are going to be excreted through the urine, but they can also be excreted through sweat. both of which are mainly made up of water. So pretty much like I said before, the main goal of metabolism is to just make that drug as water soluble as possible, so that it can just easily be passed out through the urine or through sweat. Um, so I do have to give you a homework assignment. Um, and here it is. So for the first part, just define phase one and phase two metabolism. And then for the second part, you're going to make your own little metabolism flowchart. So find a drug of your choosing aside from codeine or heroin and make a flowchart of its metabolism, noting the presence of active metabolites and then where phase one and phase two metabolism occur and with what enzymes. Yeah, you should be able to do that. Google will definitely be your friend. Um, check your resources though and make sure that you find it in a couple different places for sure. And then if you have any questions about anything that I went over today, anything about grad school or anything like that, feel free to reach out to me. My email's on the screen. Thanks. Have a great day.